Well, now it's time for some fun with vectors. This particular video is going to be vectors in 2 dimensions. So suppose that we have these points A, B, and C. First thing we're going to do is find the vector that goes from A to C. And so to do that, you just subtract. So the vector that goes from A to C, that's going to be C minus A. Then that is, so use the angle notation for vectors, and that is going to be C minus A, so that's going to be 4 minus 2 and 10 minus 1. So the vector from A to C is a 2 and a 9. Okay, just real quick, this vector 2, 9 could also be written, in some places it's written as 2i plus 9j. So that's another way to write a vector. The I is equal to 1 comma 0. So when you multiply it by 2, it means that the x value is going to be a 2. The j stands for the vector 0 comma 1. So if you multiply that by a 9, it makes the second component a 9. Personally, I prefer to use the angle brackets because when the I and j are first used, people think the I means an imaginary number, and it has nothing to do with imaginary numbers. All right, then there's even another way that vectors are written, and that is that you use round parentheses, and then you put the 2 first, and then the 9. So basically it goes from the most popular would be the angle brackets. In a close second place is the I and the j, and then in third place would be the round parentheses and write them vertically. Okay, so that was just extra for free. Now the next thing we need to do is find the vector that goes from A to B, because the goal is that we're going to find the angle A. How many degrees is angle A? Okay, so next find the vector from A to B. So that means take B minus A, and that will be an 8 minus 2 and a 3 minus 1. So the vector from A to B is 6 comma 3. All right, then find the angle, angle A. So that means that for angle A, we just need to take the cross product of the 2 vectors. Excuse me, I was jumping ahead to something else. The formula is the cosine of theta equals the dot product of AC and AB, and then the length of AC and AB. And so for the dot product, you just multiply the 2 x values, so that's going to be 2 times 6, plus you multiply the 2 y values, so that's going to be 9 times 3. And then for the length, that's going to be the square root of, so for the AC, that's going to be 2 squared plus 9 squared. And then for the AB, that's going to be 6 squared plus 3 squared. And cosine of theta equals that. So that is going to be a 12 plus a 27 on the top, so that's a 39. And then for the square roots, this is going to be 4 plus 13. Oops, where did I get a 13? 4 plus 81, so that's the square root of 85. And then for the 6 squared, that's going to be 36 plus 9, so that's the square root of 45. So then I just need to use a calculator to find out what is the cosine inverse of that fraction. So go over to the calculator, and I want the answer to be in degrees, so most likely my calculator's in radians right now. So go to degrees, And then find cosine inverse. On top there was a 39 divided by, on the bottom there's 2 square roots, which you could just put those together since it's multiplication. There's an 85 times a 45. And so it's a 50.906 degrees. All right, that's one thing that we can do with vectors. 50.906 degrees. And then the next thing that I'd like to do is find the equation of this line that goes through A and C. Well, the vector AC, that's going to tell you the direction of the line. And then you just have to pick one of the points and then add that. And then put a T right here. Basically, that stretches out the vector 2, 9. So for the next part, the line through, and I'll just put the short spelling like that, A and C is, and then I'll write it as a function of t, and the vector format would be take the 2, 9, multiply it by t, which will stretch it out as t gets bigger, and also as t gets negative, it'll stretch in the opposite direction. And then just add the point 2, 1. Or you can put all of that together and say that is going to be 2t plus 2 for the x components, and then 9t plus 1 for the y component. And then I want to graph that and see if it looks right. So instead of using my graphing calculator, I'm going to use Desmos because I can make fancy little picture like this with the points labeled and all. And then over here on the left, I have the 2t plus 2 and the 9 plus 1. I only had t range between 0 and 1, so that it only ranges from the, oops, I didn't mean to move that point, the 2, 1 to the 4, 10. So that looks like that one is correct. And then I want to make a line that's parallel. So basically I want to make this line right here that's parallel to the first line, but it goes through 8, 3. And that's very easy to do because we already have the vector for AB. So that is the 6, 3. Then just multiply that by t. And if you want it to go through 8, 3, then just add on 8, 3. And switch back to a black pen. So the line parallel to the AC vector that goes through the 8, 3. So I called the last one F. This one's going to be G for Greg. And so that's going to be take the same vector AC, so that's the 2, 9 times t, and then add on the 8, 3. And you can write that in parametric form. So that would be for the x, it's a 2t plus 8, and for the y, that's a 9t plus 3. And then go over to the Desmos and we'll see that that looks correct. So, by the way, if you want to use this on Desmos, you just start typing. So let me just add one and show you. You just start typing with the parentheses. It seems like you should use angle bracket, but this is not an angle bracket. That means less than. I know, it confused me too. So you have to use the parenthesis and then say 2, and then get the letter T right here. And when you do, it says add slider, so just click on that. So it adds a slider. And then, well, basically the slider is so that you could slide the point back and forth if you want to. If you don't want to have the slider, then you can just keep typing. And then later on, you can say, have the values go from 0 to 1 like I did there. Okay, then I wanted to check. So this second line seems to be correct. And then what's amazing is you can very easily make the line that's perpendicular. So there's the green one is perpendicular and it goes through 8, 3. So all I had to do was change the order of the 2 and the 9. So I'm basically doing the idea that perpendicular has a slope that's the negative reciprocal. So you just switch the 2 and the 9 to make it a 9 and a 2 and put a negative on one of them, and then you've got the line that's perpendicular. And it only cost about 15 seconds of work. Okay, then for the last one of this video, that is, go back to my notes, and we've got this line right here. So that's the line that goes through AC. So the last question is, when/where does the line through AC, and so to say it's a line, just put arrows on both of it, or you could write out the word line. So when does AC intersect? Oops, I spelled intersect wrong. I'm trying to hurry up and get to the math instead of the spelling. When does AC intersect the line y equals negative 2x plus 8? And I know that they have to intersect because the slope for the f1, the f of t, is 9 divided by 2. So it's just the y over the x, or in other words, the derivative of y over the derivative of x would be 9 over 2. And this one's slope is a negative 2, so they're not parallel. If they're not parallel, they have to intersect. Well, if you go back to this one, and let me just grab it real quick, make a copy and bring it back down here. So with this one, it's basically telling you that this is what x equals and this is what y equals. So we just need to plug in the 2t plus 2 for the x and the 9t plus 1 for the y. So for the y, use a 9t plus 1. For the x, use a 2t plus 2. And then it also had a plus 8 at the end. And then just do a little bit of algebra, like distribute. This would be negative 4t minus 4, and then plus an 8. And then if I put all the t's on the left side, I would need to add 4t, so that's going to be 13t. And so far on the right, there's a 4, but I need to subtract 1 from both sides. So that would be 4 minus 1, that's usually 3. And so the t is equal to 3 over 13. So if the t was in seconds, that's when it happens, after 3/13 of a second. And then for where it happens, we just need to go back to this part where I said what x equals and what y equals, and plug in the 3 over 13. So let me just make some space here. And x is equal to 2 times 3/13 plus 2. So that would be 6/13 plus 26/13. So x is equal to 32/13. And finally, just find out what y equals. So use that y is equal to 9 times t plus a 1, and then that's going to be 27/13 plus 13/13, and that's going to be 40/13. And then to make my answer look nice and fancy, so when t equals 3 over 13, they intersect at the point where x is 32/13 and y is 40/13. And that's it for today.